So our next speaker is Vafa Khalighi, and it's his second talk in this meeting. So this one is on bidirectional typesetting, and we've seen the need for that in some of the earlier talks as well. So Vafa, take it away. Tell us what you've done.
All right, thank you. So can you see my screen now?
Yes.
Okay, that's cool. I hear some echo. I don't know what's the reason.
It's Paolo. I'm going to mute you, Paolo. There we go. And now unmute myself.
Okay, so I'm going to talk about bidirectional typesetting in TeX. And I want to start by saying a few things about myself. So I was born in a Baha'i family in Iran. From my father's side, we were the very first Baha'is in Hamadan, which dates back to about 107 years ago. And from my mother's side, my grandfather became a Baha'i long before the Iranian Revolution. The main teaching of the Baha'i faith is the unity of mankind. After the revolution, Baha'is have been persecuted by the new regime because obviously we are not Muslim, so they cannot tolerate us. As a result, a lot of Baha'is have had to leave Iran, including me and my close relatives. So I now have close relatives in Canada, United States, and other parts of the world. I'm just going to say that Parramatta is just a suburb in Sydney. And in the Baha'i community of Parramatta, we used to have a monthly Persian magazine called Melody of Love. And when I say monthly, I don't necessarily mean 30 days, because in a Baha'i year, there are 19 months, and each month has 19 days. So this magazine used to be published every 19 days. So what got me interested in the bidirectional typesetting in TeX was the typesetting of this magazine. And I've been using to implement solutions to typeset this magazine. So just to give you a little bit of perspective, I'm not sure if you have ever been in a Baha'i house of worship. The left image shows the Baha'i house of worship in Sydney, and the right image shows the one in the United States. I'm not quite sure where exactly that is, but I think that's in the United States. There also used to be a Baha'i house of worship in Tehran, but at the end of the Pahlavi era, it was disrupted by Muslims. And if you're wondering what's the inside of the house of worship looks like, this is the one from Sydney. The distinguishing feature is that the house of worship is not just for Baha'is. Anyone can go there and say their prayer. So it doesn't matter what religion you have, you're more than welcome to go there and say your prayer. So what's the bidi package? It's a package for typesetting both left to right and right to left text, short and long. And this doesn't mean just the ordinary text. You have to do a lot of other things. I'm not a French, but I'm going to try to say this. It was initially developed by Francois, and this was a very small package and quite limited. As I was working on the Z Persian package, I saw a lot of issues with the bidi package, so I sent patches to Francois and fixed those issues. Later, Francois didn't have time for the bidi package due to other commitments, and he asked me to maintain it. And I have maintained the bidi package since 2007, except a short period of time when, due to health complications, I asked David and the LaTeX team to maintain it, and they kindly accepted, thanks to them. So initially the bidi package was very small, but it grew to be so big that it now supports more than 200 commonly used packages. So you can use the bidi package with those 200 packages and typeset your documents. Some of these 200 packages require little modifications, but the others need a lot of changes. Any of these packages, because they're frequently used, they updated regularly. So whenever a package in these 200 packages are modified, I have to update bidi changes as well. Otherwise, things doesn't work anymore. The bidi package runs under the ZTeX engine and works with both plain text and LaTeX formats, but most of the users just use LaTeX, so there are not many people who use plain text with the bidi package. Since bidi package relies on the ZTeX engine, it works with any engine that supports TeX-Z bidirectional algorithm, including PDF-TeX. And the bidi package is considered a core package. It is used in several other packages, including Arab ZTeX, Polyglossia, Z Persian, and I think Babel use it as well, because initially Javier wanted to do everything himself, but when he saw that what a mess the TeX-Z algorithm is, he just gave up and used the bidi package instead. But if I'm wrong, please correct me. Although the main objective of the bidi package is to typeset right to left documents, and if that process, it does other general things. So it provides a lot of programming tools and does other general things, which I'm going to talk about some of them today. The bidi package is used for typesetting Arabic, Hebrew, Persian, Kurdish, and any other languages that you need to write from right to left. It is also used for linguistic purposes. Other than the native speakers, there are also researchers in the Western universities where they need to publish research on Persian or Arabic or other languages written from right to left. That's why they need to use the bidi package. I'm not a user of the package, I'm just a developer. So I receive bug reports, I fix them, users ask for features, I implement them, answer questions, and then release the package on CTA. In developing the bidi package, I have benefited from discussion with the Persian tech community and the Israeli tech community, the Ivri Tech mailing list. My goal in this talk is to actually show you what are some of the issues with the TeX-Z algorithm and how we need to actually fix them. So just to give you an example of a book that was typeset by the bidi package is the book From Alexandria Through Baghdad, published by Springer. And this is just a title page where the authors wrote something for me on that. I'm not sure if it's readable or not. So what do we have? So we're using ZTeX. We have access to eTeX. We have TeX-Z algorithm, but the TeX-Z algorithm is not enabled by default. So what do we have? So first we have the TeX-Z state. This is just a state variable, which is an integer parameter. And if positive, mixed typesetting is enabled. Otherwise, the behavior, the construction of horizontal lists and paragraph is exactly identical to TeX3. So if you don't enable, if you don't give a positive integer to TeX-Z state, the primitives begin L, NL, begin R, NR are not available. So once we have enabled mixed typesetting, we have access to 4 primitives for mixed typesetting. As I said, begin L, end L, begin R, and end R. And these are horizontal commands, so they're not vertical. And they need to be matched. So begin L needs to be followed by end L, and begin R needs to be followed by end R. You can't just use begin L or end L and expect things to work. I think you get some error messages or warnings from TeX. There's also pre-display direction, which allows you to change the position of the equation numbers using the primitives ECNO and LECNO, but this primitive is actually broken in right-to-left mode. What I mean by broken is that if you use pre-display direction in right-to-left mode, the spacing before a display mat and the spacing after the display mat is uneven. So sometimes it's less, sometimes it's bigger than what it needs to be. There's also, as I mentioned in my other talks, there is no primitive for changing the direction of H-align directly. So we have to use a trick. So to make tabular right to left, H-align is the primitive that used inside H-align that is used inside tabular for those who don't know about primitives in TeX. So the construction that we need to use is that we need to put H-align inside an H-box and then surround that H-box by begin R and end R. Now this creates a number of other issues. So if there are indented items inside H-align, which are created using the primitive hang indent and or pear shape, the indentation will go wrong. So what I mean here is that the indentation gets reversed, and something that is supposed to be on the right-hand side ends up on the left-hand side and vice versa. So this is quite complicated. Most importantly, what sets are reversed and special pairs are placed in the wrong order in the right-left mode. This means there are issues with color, hyperlinks, including graphics, rotating text, reflection, scaling, and any other graphical instructions which you want to send to the driver using the special primitive in the right-to-left mode. These issues are not at the macro level, they are at the engine level. So things are broken fundamentally at the very lowest level. This is already complicated. Imagine what the bidi package have to do to achieve its goal. We want to support more than 200 packages and it's the typesetting of right to left. So what can we do when things are this bad? So how do we use the package? In plain TeX, you just have a simple file. You just input bidi or bidi.tex. You use the set RTL command for typesetting right to left text. You write your text and then you process your TeX file with ZTeX and you get your PDF output. The control sequence sets RTL typeset paragraphs right to left. And if there is text before this control sequence, you need to have a blank line before this control sequence. Otherwise, it doesn't work. And we also have set LTR for typesetting paragraphs in left-right mode. In LaTeX, this is also quite simple. We just have a simple document. The only extra bit is the loading of the bidi package. So you load the bidi package, and then you use the set RTL command for typesetting right to left paragraphs. And the rest is just the same way that you would write any other LaTeX document. Now, this time you run zLaTeX on your TeX file and you get your PDF output. So I want to talk about some of the features that the bidi package does for you. One of them is the PDF encryption. So this has nothing to do with the bidi package. It's just a feature that was asked by users and it was implemented. So we can encrypt the PDF file using the PDF encrypt setup. So the options that you have here is the user password, the owner password, the key lengths, and the permission flags. Permission flags are the things that you can do if you want to make your PDF printable, editable, whatever. No magic is done here. Everything is passed to the driver using a special. So these are actually the features of the DVI PDFMX driver. And this is just the interface everything is done by the driver. And the control sequence PDF encrypt setup is only allowed to be in the preamble of your document. If you don't give any values for user password and owner password, or if they are empty, no encryption is done. So there's no empty password encryption. I also want to talk about other important options. The first option is document direction. What happens is that you tell the bidi package what the main direction of your document is. And it has two values, right to left and left to right. And if you give the right to left, it typeset everything in a right to left mode. There's also the table direction option. This also has two values, right to left and left to right. It typeset tabular material right to left. And it's not just the tabular material from LaTeX, it's the tabular material from every single LaTeX package that allows you to typeset tables. There is also an option for footnote rule. This is the option that allows you to control the behavior of the footnote rule, and it has 5 possible values. There is automatic, there is left, there's right, there is split, there is text width. So the easier one is just the text width. What this does is that the footnote rule is as wide as the text width on every single page. The split options means that whenever a footnote is split on the page that the footnote is split, the footnote rule will be as wide as the text width. The right means that the footnote rule is always on every single page is on the right-hand side, and left means the other thing, so it's always on the left-hand side. Automatic is a bit different. So what automatic means is that if on a given page, the first footnote is a right to left one, the footnote rule is typeset on the right-hand side. But if the first footnote is a left to right one, then you have to typeset the footnote rule on the left-hand side. When I say you, I mean the bidi package. So the bidi package does this automatically, or let's say more explicitly, the TeX actually does this, not the bidi package. Bidi package just sends low-level instructions to TeX. There's also footnote direction option. This also has 2 values, right to left and left to right. You obviously want to typeset your footnotes either in right to left mode or left to right mode. There's also an option called extra footnote features, which allows you to typeset footnote with extra features. Mainly, these are not all the features, but mainly it allows you to typeset footnotes in paragraph format and in multiple columns. So you can have a maximum of 10 columns of footnotes on a particular page. There's also a per page footnote, which resends the counter on every single page. This is done entirely. This is done internally without loading any external packages. So this is done all by the bidi package. We don't load any other, we don't use any other packages. So now I want to talk about some of the things that bidi package does. And I want to give you a very simplified version of what the bidi package does. So the first thing that we want to do, we want to make paragraphs right to left mode. So the main thing here is this thing, the command RTL every path. So what we do, we use the set box, and we want to allocate the box 0 to be the last box. Then we put begin R. If box 0 is void and it's nothing in it, we do nothing, but otherwise we typeset that. And the begin R before here, it makes the paragraph right to left. The rest of this is just for token list. And so you can have things inside the every path, and the things before it and after it doesn't get lost. Now you want to switch paragraphs back to left to right mode, the solution is simple. We just need to use a Boolean and use begin L instead begin R in the above code. Now, you might wonder if the use of begin L is necessary, and the answer is because if we want to have constructions like HBox, where things are written right to left and inside HBox, then we need to have this begin L. Otherwise, there is no effect. So now we want to make short pieces of text right to left. What we have to do, you might be tempted to think that this is the solution. It's quite simple. It's nice. It's very short. You can do it. You don't need a package, but this is not robust enough. For instance, you can try to put a verbatim inside this command and you get error. The right solution is a bit complicated, and this is the simplified versions that the bidi package does. And we have to check if the braces match each other. If it doesn't match, then we're printing the message that the left brace has been substituted. We can define a similar control sequence for ShortLTR text, where obviously in the above code, whenever you see begin R, it's only one instance. So we have to change this begin R to begin L and the end R to end L. Okay, so how do we make the tables right to left? So this time, I'm not going to talk about every single package. The bidi package does this for every single package, but I'm going to just talk about the later kernel, not every other package, but the process is similar. So you look at the macro at array, and at the end and before at printable, you put an HBox, and inside that HBox, you put begin R. Obviously, you need to end that HBox, the grouping of that HBox. So in end tabular, you just put end R and then a group. As I said, this is a very simplified version of what the bidi package does, and a lot of unwanted things happen, and we need to make sure that we get the right output in every single of these cases. So we have to check every single of those cases. We also don't want to typeset the contents of array environment, which is used in math modes right to left, because at least in Persian and Hebrew, math is always typeset from left to right. So we need to make sure that the array environment, which is typeset in math mode, is written from left to right. This is the feature that is shared between array and tabular. So next, we want to put an HBox and the material in a right to left mode, but in vertical mode, the HBox is actually typeset left to right. So we want to define a control sequence HBox R that behaves like the primitive HBox, but its contents is right to left. Again, the definition that I have given here is a very simplified version of the one in the bidi package. And once you do this definition, you can now do things like HBox R to, for example, 30 PT, and then typeset your box. The next issue that we want to look at is how to make the columns right to left. And for that, obviously, I'm not going to talk about a very complicated solution. So I'm just going to concentrate on the two-column option of the later kernel. So you want to pass the two-column option to your document class to typeset your document in two columns. Generally, you would do this, you pass the option two column to your document class, which is article here. You also want the columns to be typeset right to left. But the columns are not typeset right to left, so you have to do extra work. This is done in the output routine, and what we are interested in is a macro called output dbl call. So this has a long definition, but I'm going to concentrate on the part that I have interest in. So if you look at the, what happened? So if you look at the definition of output DBL call, this is the definition that you have. There is some stuff before, but this is the part that I'm interested in. So there's a V box here, then you put an H box as wide as text width, then you put another H box as wide as the column width, you put your first box here, then you put the rule that separates the two columns here, and at the end you also put the second or the last column. You might wonder if what happens if you use begin R and end R inside this construction. So what happens if I put begin R here and end R at the end of it? Well, I already told you that in Tabular that creates a mess. So it complicates things. Other than that, the table of contents are also typeset in the reverse order. What I mean by this is that if you, in your first column, you put one section, and in the second column, you put another section, in your table of contents, those section appears in the reverse order. So instead of getting one section one, two section two, you actually get two section two, one section one. So the other thing that you might think is that you can change the places of at left column and at output box that occur in that macro. But that also suffers from the same issue. So for example, the table of contents, the order of the table of contents is not right. So to achieve our initial goal of typesetting columns right to left and getting the right output, we have to full TeX. And this is, again, the simplified version of the solution that the bidi package does. So these are all the same things. I'm just going to show you what is different. So these are all the same, but what we do, we first skip as much as the column widths. So initially, we don't typeset anything in the first column, okay? Then there is a rule which comes and separates the columns. And then we have an H box as wide as the column width. So this is actually in the second column because we skipped the first column. And then we put the left column there, but then we have to skip to the beginning of the text and then put an H box as wide as the column width and then put output box there. As you can see, this is a bit tricky. So this is the only way that we can make sure that we can typeset a two-column documents in right to left mode and things work correctly. The next issue is the equation numbers. So in right to left mode, ECNO becomes LECNO and LECNO becomes ECNO. What I mean by that is that whenever you use ECNO, the equation in the right to left mode typeset on the left-hand side, and the equation using LECNO is typeset on the right-hand side. But we want ECNO to place equation numbers on the right-hand side and LECNO to place the equation number on the left-hand side. This is actually, this was a requirement of the Iranian Mathematical Society. So we have the primitive pre-display direction, but as I said, this is broken. The vertical spacing before and after display mat is uneven if you use that primitive. The solution is very simple. We just save a control sequence for ECNO and another control sequence for LECNO. And if the value, the integer value of pre-display direction is negative, we just swap ECNO and LECNO. Otherwise, they're the same thing. Finally, I want to talk about the plan for future. So far, I've talked about the few existing issues and gave you a simplified version of the solution that the bidi package employs. So whatever that I said is not something that an end user does, but it's something that the bidi package internally does. I hope that I was able to convince you that the bidi package suffers from a lot of issues at the engine level, but it tries really very hard to overcome most of these issues. They are not simple issues because the things are broken fundamentally at the engine level. So we don't have much choice here. This morning, I was listening to Jennifer talks on YouTube, and actually the LaTeX end users don't know much about the engine issues and don't really care. All they want to typeset a document in peace, and they want it to work. Sadly, the TeX algorithm is not maintained, and I already discussed these issues with the author of eTech, Peter, and he was working to fix this, but sadly he passed away. For some time, I've been working on a format called bidi. It runs under the LaTeX engine, and unlike bidi, this is a format, not a package. So what this does is that it loads the LaTeX format, it does some changes to the LaTeX format, then in those changes, the use packages and document class, load class, those control sequences are modified. So whenever a package, say the package color is loaded, the format looks for a file called bidi color.def. If that file exists, it loads that file. Otherwise, it doesn't do anything. So inside that definition file, there are changes to the color package. As I said, this is not officially released, but it's still under development. And it's in parallel development with the Persian LaTeX package, which I mentioned yesterday. Okay, so you might think that, well, there is LaTeX, why don't you use LaTeX? LaTeX has better right-to-left support than TeX, but there are also issues with LaTeX. So, for example, this is one particular issue that I want to show you. So what happens if you typeset this document? So you have a paragraph TRT, which typesets a paragraph in right to left. And there is also a text dir primitive, which typesets the direction of the text becomes RTL. Now we want to typeset a display mat, and we want to put an equation number on the left-hand side. So you don't have to trust my word for it. So I'm going to demonstrate what happens. So I have the same file here, which is exactly that file. And let's run LaTeX on it. Okay, and let's look at the output and see what we get. This is okay, but see where the display mat is gone and where is the equation number. Okay, so this particular issue, I reported it several years ago, but still exists and not fixed. There's also a LoWBD package available on CTAN, which sort of supports the LaTeX engine, but it's very elementary, and it's derived from my earlier work in 2009. I think that was all I was going to talk about. Thank you so much for listening to my talk.
Well, thank you, Vafa. So, do we have any questions on any of this work, which is clearly important work? No, nothing there. Yes, Boris is giving his praise in the chat. Very important, very good. Aha, comes a question from Victor, again in the chat. So
yes, I mentioned the Iranian Mathematical Society. I was giving a talk yesterday about the Persian typesetting, and yes, I think I mentioned yesterday that the publication of the Iranian Mathematical Society yesterday. I mentioned yesterday that the Iranian Mathematical Society publishes all of its publications by the Z Persian package, which I talked about yesterday. And what powers the bidi package is what powers the Z Persian package is actually the bidi package. So if you go to the website of the Iranian Mathematical Society, let me show you. I think it's called ims.ir. If you go to the website of the Iranian Mathematical Society, so this is the website, and this is the new website. But if you go to the old website,
so you're not sharing that, Vafa?
I'm not sharing. Sorry.
No.
Okay. So can you see my browser now?
Yeah.
Okay, so this is the website of the Iranian Mathematical Society. And if you look at this website, they have a lot of publications. So this is their bulletin. So if you look on that, now this whole document is typeset using the Z Persian package, which is powered by the bidi package. This is just mainly for the communications with the mathematicians inside Iran. Another example that I can show you is another mathematician in IPM. I think he's Iman Eftekhari. Okay. Okay, and he's written some articles in Persian at the end of his webpage. He has an article on the work of Maryam Mirzakhani, and all of these documents are typeset by the Z Persian package. So this is the article that he wrote on the work of Maryam Mirzakhani and what gave her a field medal. So this is how things are typeset in Persian. And this is all powered by the Z Persian package and the bidi package. So it's used quite widely in Iranian academia. I hope that answers your question, Victor.
So, any more questions from anyone? If they're not, then well, let's thank Vafa. So